All right, let's take a look at the next section here. So we're kind of changing gears a little bit here. This section's got two parts to it. The first part, luckily, we've already really done. We're just going to kind of recap it, and then maybe something new for you guys. Maybe you saw in Algebra 2. We'll check it out in the second part. So I want to look at factored form versus the general form. So we did this for polynomial functions in Unit 1A, and now we're doing rational functions in Unit 1B. There's pros and cons to the factored form and the general form, or sometimes this in a polynomial is called standard form. Let's look at what you could tell from each section. So when I'm looking at factored form, when it's like this is really good for seeing the zeros. It's also really good for seeing the multiplicity of those zeros. Does it bounce off? Does it cross through? That's why we have factored form. Standard form is really good to see the degree of the polynomial. There it is, fourth degree up front. It's also good for finding the y-intercept right there at 5. So it's kind of like pros and cons to each of them. Awesome. How about over here in rational land? When it's factored domain, yes, I can see that domain nice and neat on bottom. I can also see any potential holes in there. Looks like -4 is going to produce a hole. I can see the zeros by seeing what's happening on top. And I can see vertical asymptotes. So that's what we've been kind of doing here in the beginning part of this unit. Could I multiply that all together? Sure, and make some kind of general form? Sure. What's good about this? Remember, the horizontal asymptotes is the power on of the bottom bigger than the top. If it dominates it, it goes to 0, that type of thing. And it's really nice for seeing those y-intercepts. If you put 0 in, what comes out, you can see it's -8 over -2. So pros and cons to each. We're just going to kind of toggle back and forth between the two. So let's do two examples real quick. If I have this, so again, y, it's in standard form, so I can see, oh yeah, it's a third degree polynomial, which is nice because I know third degree polynomials are leading coefficients positive. I know it's going to make this shape right here, and that helps me do the in behavior. So right off the bat, I kind of get an idea of, sure, I'll write it down here. As I go to the left, or the negative infinity, what's the function doing? And then as I go to the right, I like to write it all out first, as I go to the right. So you did all that way back when, man. That's old school checking out in behavior of polynomials. And once I write that out, let's plug it in real quick. Because I knew the degree and the new leading coefficient made this shape, I know it looks like it goes to negative infinity to the left, and it increases to positive infinity to the right. So just a quick review of that. Y-intercept, there isn't one, but if there was a constant here, in this case it's 0, you just plug x is 0, so in this case the y-intercept is actually zeros. Now I'm kind of stuck. That was it for this form. That was great, enjoyed it, but I'm kind of stuck here. So now I'm going to have to factor to find the 0. So what do they all have in common? They all have like a 2x in common, and that's going to leave me with what here? If you take out an x, the 2x, you're left with x squared. 16 divided by 2 is 8. Got that x here, and then this is just 16. Okay, it looks like a double factor here, so does the inside break down again? Sure. What multiplies to 16 and adds to 8? You're going to end up with something like this, so it looks like x minus 4, and x minus 4, yeah? So 4 and 4 is 16. Get them together, you get -8. If you wanted to even clean that up a little bit more, you could say something like this is x minus 4 squared. So all these different ways you can write it show you different things. Now I'm finally ready to say, where are the zeros? The zeros, I'll put them in a different color. Look like they're going to happen here at 0 and +4. That's also +4. So that's going to be my zeros. Awesome. 0 and 4. And then where is it positive? Well, I can kind of tell because of the picture. I have a rough idea. And these zeros, I can make a super rough sketch that, hey, okay, I know it crosses at 0 and 4. And then if I look at the multiplicity in this shape, I know there's going to be a bounce here at 4 because this is where it's an even power up there. And it's got to follow that shape. So it's got to look something like this. So where is this bad boy positive? It looks like it's a positive. Once it hits 0, it stays positive. So really, it's going to be positive anywhere from 0 to infinity. Awesome. So that's kind of a blast from the past there. Excellent. How about with rational functions? Same thing. Usually we get it factored and it looks nice. We can do the domain and range. I say, oh yeah, there's a problem at -3 and 1. There's something hopefully interesting going on at 0, 5. So the domain is the bottom. So real quick, I can exist from negative infinity to -3, and union with from -3 to 1, and then from 1 to infinity. Oh, I forgot the union. I forgot about you. Okay, let's try that again. And union with 1 to infinity. Awesome. So real quick for domain, Highlight the zeros, so it's kind of a recap. On top, I can see the zeros. Nobody's canceling out or doing anything tricky, so it looks like we've got 0 and 5 for our zeros in this case. And then any holes? No, nobody cancels, so I have no holes. Any vertical asymptotes? Sure, the whole bottom there. We've got -3 as a problem, and we've got 1. So we're kind of putting it all together here. And then horizontal asymptote. Now I'm ready for the other form. So ideally, I'd rather have it in that general form, so I'd like to distribute the top. I'd like to multiply it out and say, okay, the top is really 3x squared minus 15x. And then the bottom is going to be what? Multiply that out, do a double FOIL, it'll be x times x is x squared. We're going to say minus an x plus 3x will be plus 2x. And then plus 3 minus 1 is minus 3. So I skipped the step there. You can multiply it out, show all your work if you like. But again, I'm really just caring about the horizontal asymptote. I see the powers are the same. So because the powers are the same, I'm going to take that leading coefficient, which is 3 over 1, which is just 3. So we need it in that general form for that. How about y-intercept? So if x is 0, all I care about are these constants. Again, there's no constant up here. That's just plain old 0. So you've got 0 over 3 as your y-intercept. That just equals 0. So it's going to cross at 0. So you got to be good at going back and forth, which you were doing the whole time anyway. So I don't think that's anything really new. It's just a little practice switching it around. Awesome. Let's get to the second part. I did the part really fast. Let's get to the second part, which you may not have seen, and it's a great theorem here. We're going to talk binomial theorem. It has a lot of cool uses. Let's talk multiplying. So I've got this idea, and maybe I want to expand this. I want it in that general form, standard form. So what does this mean? Well, it really means x plus 5 times x plus 5. And I'm going to multiply quickly here. If you need a recap on this, you can review this. But I'm going to do double distribute or FOIL or whatever you learned here, box method. And basically, I'm going to come up with what? X times x is x squared. Then I'm going to say 5x and 5x is 10x. And then I'm going to say 5 and 5 is 25. So I don't mind multiplying that out. That's pretty chill. I'm pretty happy about that. But check out this next one. What about if I want to cube it? Now I'm talking about x plus 5. That's a terrible looking 5 times x plus 5 times x plus 5. Okay, this is starting to become a little tedious here, but I can still do it. I'm not too salty yet. If I do x and multiply these three out, I know the first part, right? I just did it. X plus 5 times x plus 5. I already know will give me x squared plus 10x. I'll write this bad boy down. Plus 25. But now I got to multiply that by x plus 5. So this is going to create a lot of terms here. So no worries. Let's just do it. So I'm going to distribute that x to everybody. So I'm going to take up a lot of space here. So x squared becomes x cubed. 10x becomes 10x squared. What's next? 25 becomes 25x. And then what's this? Now I'm going to do the 5 to everybody. Everybody gets that 5. So this will be 5x squared. Oh my goodness. And then what? 5 times 10 is 50. And I'm not showing all the work. I'm just kind of doing it. I hope that's okay. And then 5 times 25 is 125. And now here I got to clean it up. Who is a match? Who can I add together? So I'm going to kind of write it off to the side if that's cool. I'm going to come over here if that's cool. And say x cubed, there are no other x cubes. How many x squareds? I've got 10x squareds here. I've got 5x squareds here. So I'm going to have 15x squareds. Luckily, I am going to show you a shortcut. If that's what you're waiting for right now, there is another way. I just want to show you how painful it is. 25x times 50, I'm sorry, not times, plus 50, 75x. And then what else do I got here? Do I have any numbers? I've got 125 right there. So that's pretty cool. That's pretty awesome. Do I want to do the next one? I don't. I really don't want to do that next one. So is there a faster way? Turns out there is. So a mathematician named Pascal made this triangle, and it's got a lot of cool patterns in it. But here's how you make this little triangle right here. If we start with 1, and then on the outside we're going to put a 1 and a 1 here. What we're going to do is we're going to kind of add things together. You always start with a 1. Well, what is 1 plus 1? That is 2. And then I'm going to put a 1 on the end. So right now, let's just build the triangle. We'll talk about it. So start with a 1. Now add 1 and 2. These together will give you 3. 2 and 1 over here gives you 3. And then you end in 1. So start with a 1. 1 and 3 is 4. 3 and 3 is 6. 3 and 1 is 4. end with a 1. So you can kind of see it building and hopefully see some patterns going on here. 1 and 4 is 5. 4 and 6 is 10. 6 and 4 is 10. 4 and 1 is 5. And 1. Let's just do one more row. See if we can get it. 1 and 5 is 6. 5 and 10 is 15. 10 and 10 is 20. 10 and 5 is 15. 5 and 1 is 6. And it's kind of symmetric here. You can keep going as long as you want. So how in the world is this going to help us multiply? Well, check it out, man. So we're going to call the first row up here row 0. So that's anything basically to the 0 power. This next row right here will be 1. Then we're going to go 2. We're going to go 3, 4, 5, and 6. So you can kind of even see it counting. There's all kinds of crazy patterns in here. So if I want to do something to the 4th power, so check it out. This is raised to the 4th power, so I go to the 4th row right here. This is my row of interest. So what I'm going to do is I'm going to kind of skip all this multiplying, and I'm going to use the row. This will actually help me, will get the coefficients for me. So what does that mean? So basically, this first term we call A. This is my A term. This is my B term. So this is going to be A and B. Whatever is there, we're going to go ahead and they're going to be important for finding this like final monster answer we got down there. So how do we do this? So I got row 4. So I'm going to start with that 1. I'm going to take A and I'm going to times it by B. Then I'm going to say, okay, that's cool. Plus, what's the next one? 4. A times B. Then I'm going to say, what's the next one? 6. A times B. Then I'm going to say 4 again. The next one in the row is 4. So it's giving me the coefficients of these things right here. And then the last one's going to be 1A times B. But you see how the powers are changing. The powers are going to change here too. So I'm doing 4th degree. So the A would actually be the first one. This would be the 4th. This would actually, and then this A counts down. It goes to 3. Then this is A squared. This is A1. And this is A0. B does the opposite. B starts at 0 and B counts its way up. 0, 1, 2, 3, 4. So what I normally do, I was just kind of showing you the generic formula. I normally just plug these bad boys right in. So let's do that. It still takes paper. It still takes some space here, but it's better than multiplying that all out. So A was x. So this is really 1x to the 4th. What's B to the 0? Well, the B term is, I'll write it this time, but I don't always write this one because what is anything to the 0 power? The B term's 5. Any 0 power is just 1, so you don't really have to write 0 terms. So this will be 4, the first term x cubed. The second term, which is 5, is going to be 1. Then it's going to be 6. Woo! The first term, which is x, and I'm going to square it. The second term is 5, and what are we up to here? It looks like b is at 2, is also squared. And then I've got 4. The first term is x again to the first power. The second term is 5. And what's he counting up to? He looks like he's cubed. And then the last one has got a coefficient of 1. The first term of x is at the 0 power. And then the last one is at the what power? Built up to 4. So this may seem really weird at first, but give it a second. We'll do another example. It'll become much more clearer. I don't know if that's a word. Become much more clear. Okay, once you can set up, it's just cleaning it up. So 5 to the 0 is just 1. This would be x to the 4th. You can write times 1 if you want, but that's not going to do anything there. How about here? I've got 4 times 5 to the 1st, so 4 times 5 is 20. And this is x to the 3rd power. So we're just cleaning it up now. All I got to do is clean it up. 6 times 5 squared. 5 squared is 25. So 25 times 6 is 150. So I'm going to go 150. X squared. And then I'm going to go the next one, 4 times 5 cubed. 5 cubed is 125. 125 times 4, I believe, is 500. Yeah? Woo. Mental math right there. And then there's just an x to the 1st power. And then the last one is 1. 1 times x to the 0, this is just 1. You know, that's just 1. Just like over here, 5 to the 0 is just 1. So when you're timing, it doesn't matter. So what is 5 to the 4th? I believe that's 625. You can use a calculator to help you out if you need to. That is it multiplied out. So notice I didn't have to do this whole distribute because it would be so tedious. That is the answer right there without distributing. And if you want to go back and check this, you could. It would give you the answer for 3. You just use the row above it. So if you wanted to go multiply a third power, you use this. Holy cow, that was intense. Let's try it again. I don't think it's hard to see it your first time. So let's say I want to multiply this out. Definitely don't want to do it. If I had to multiply it out, it would be a whole sheet of paper. So I'm going to use the binomial theorem. I went ahead and put Pascal's triangle over there so I could reference it. Let's go ahead and highlight this bad boy. I'm looking at the, 0, 1, 2, 3, 4, fifth row. There it is right there. This is the row of interest for me. And let's set it up again. This time, I'm going to not do A and B. I'm just going to go first term, second term. I think it's a little cleaner if you can go there. So the leading coefficient is 1. So I've got 1 times x. And the first time through, I like to just write it. You can put the exponents in if you want. I'm just going to write it out. There's A times B. I'll come back and do the exponents. Then the next thing is 5. The next coefficient is 5. A term is x. B term is -3. Make sure you have that negative in there. And then I've got what happens here, 10. And this is x. These do take a while. Sorry about that. The second term is -3. And then, oh, I got another one of those. Well, that'll be easy to clean up. 10, A first term, second term. And then, oh my goodness, I'm going to run out of room. I've got 5. First term, we've got x. Second term, -3. And then what do I got? Can I move this? Let's see if I can move this. I hope I can. Whew. I didn't know he was going to get in the way there. All right, hopefully he's safe down there. So what was that, 5? So I'm hitting each coefficient here. And I'm on the last one plus that 1, x minus 3. Nice. Okay, now it's just a cleanup game. That's it. And let me go ahead and put the exponents on. So the A term, the first term counts down. So it starts at the 5. So he's going to be to the 5th power. He counts down to the 4th power, to the 3rd power, to the 2nd power, to the 1 power, to the no power. And then I'll even go different color here. For B, B starts low. The second term starts low, 0, 1, 2, 3, 4, and 5. Awesome. Now the cleanup begins. Can we clean this up? So anything to 0 power is just 1, so you're timesing, who cares? So I'm going to start this whole thing off with x to the 5th power. That's a good start. 5 times 3, -3. So be careful, it's -3 to the 1, which is -3. So this will be -15. X to the 4th. Not too shabby so far. X to the 4th. -3 squared is positive, so it's 9. 9 times 10. I got this right here going on. That's going to be 90. And then what's in the parentheses? We've got x cubed. And excellent. Then I'm over here again. But, ooh, now it's -3 cubed, so it will be negative. That's -27. 3 times 3 times 3 is -27. Times that 10 is -270. And I'll have the x squared. Then I come over here, -3 to the 4th, I believe is 81, and it's positive. 81 times 5, I believe is 405. Maybe want to check my mental math. I think that's good. So that's x to the 1 is x. Again, that's just 1, so it's 1 times 1 times -3 to the 5th. So what is that? We got 9, 27, 81, 243. And it is an odd power, so it'll be -243. Now, if you need more steps to write out, that's cool. I was doing a lot of that in my head, or maybe you can put in your calculator a little bit, crunch those numbers. But it is just the cleanup stage. So yes, I don't want to multiply all that out. This is the answer right here. It's a mess, but imagine multiplying all that out and combine like terms and how terrible that would be. That would not be fun. A cool little trick on this, when you do have a negative second term, notice the signs will alternate from negative, positive, negative, positive, negative, because you've got those even and odd powers going on. So you will have to do a couple of these monster long problems. I apologize. This problem will not be a monster problem. This is a little bit shorter, so it still tests to make sure you can know what's going on, but it's just a little less work. So let's try this. Let me get my highlighter out. I know I'm going to the 6, so I'm going to go down here to row 6. Here's row 6. It's always this, counts 1, 2, 3, 4, 5, 6. The first one's just 0. There's my row, but I only want the third term, so that's all I really care about is that third term. So there's the first term, second term, third term. So I circle the guy I'm interested in. That's the third term, so I know the leading coefficient is 5. Then I go ahead and say, what is x? X is, I'm sorry, what is the first term? 2x. What is the second term? 3. And then what's the counting process here? So remember, the first term starts high, so it goes 6, 5, 4, 3, 2, 1, 0. So it's 6, 5, 4. So this will be to the 4th power. And then the other one starts at 0, 0, 1, 2. So there's 2. That's the answer, but we're going to clean it up. Oh, so let's clean this up. This one I'm going to spend a little more time cleaning up because it's kind of intense. So we've got the 15. What happens here? So 2 to the 4, so what is that? 16? 2 times 2 is 4, 8, 16. 16x to the 4th, and then 3 times 3 is 9. So in this case, I mean, you can bust out some multiplication skills if you want. I'm not going to lie. I'm going to look at the calculator right now on that one. So we're going to say 15 times 16 times 9, and that's going to give us 2,160. That was not mental math. I'm not going to pretend like it was. And then x to the 4th. So if I'm just looking for the third term, I don't want the whole series. Like this is the third term of this sequence right here. This is the third term. I don't have to do the whole show right there. As long as you can count down and count up on your exponents, you're cool. You're good to go. Excellent. I know it was a long video. Good luck on the practice and on the master check. Peace out.